The first question that I want to do with you is a question on the quadratic function. So Rav, you're writing next week, Friday. Okay, so you've still got a little bit of time. Okay, so the first question that I want to do with you guys this evening is a functions question, and it is a parabola and a straight line. So it says to us, sketch below, we have the graphs of f of x equals minus 2x squared plus 4x plus 16 and g of x equals 2x plus 4. They tell us that A and B are the x-intercepts of f and C is the turning point. And then they give us a bunch of questions to answer. So we can see there, that's about 18 marks worth of questions. And then they've also got some inverse functions included in this. So we'll have a look at that. We're able to sort of kill two birds with one stone, so to speak. Okay, so the first thing that they want us to do is calculate the coordinates of A and B. That's fairly simple. That is a level 1, level 2 sort of question. The second thing that they want us to do is determine the coordinates of the turning point. All right, so what I'd like is for you guys to try and do questions 5.1 and 5.2 on your own. And I'm going to give you guys, let's see how many marks it is. It's 5 marks. So I'm going to give you 6 minutes. Let's see what you come up with. When you're done, you can DM either Yolanda or myself your answers. And then we'll start talking about the others together. Okay, so you guys are doing 5.1 and 5.2, please. You can't see the graph properly. Okay, so Lesejo, there you go. Is that a bit better? It's there in the middle. So A and B, you can see them now.
Yeah, on my side, I can see the whole diagram. Okay, it's visible.
Okay, good.
Fine.
Good, Nhlanhla, well done. Nhlanhla, go and have a look at question 5.3. I'm just going to move this over a little bit. It's not going to interfere with anything. And have a look at 5.3 and maybe at 5.4 in Nhlanhla. Rosario, you're saying, where are you? I'm giving you guys some work to do. You're going to do 5.1 and 5.2. We've just started, okay? You're going to calculate the coordinates of A and B and the coordinates of C, the turning point. Okay. Okay. Good, Ntokozo. Good, Ntokozo, that's perfect. Good, Lesego, nice. Lovely. So all the answers coming through for the first 2 or 3 questions are correct. Good, Mamelo. Nice, Iviwe. Good job. Lovely. And so nicely typed as well. So neat. It's okay, Cheslin, no stress. I understand you guys have got to write and still try and type on your phones. It's not easy. Okay, so if you have done 5.2, you can do 5.3. 5.4, we may need to talk about. I'll start slowly on 5.1 down here now that a whole bunch of you have sent through. That's it, Cheslin. Good. Well done on both your answers. Okay, Cheslin, I got a different answer for the coordinates at C. Perhaps you can explain to me how you got those numbers that you've sent through. Because I got a different answer to you. Not that I'm saying I'm correct, but mine was different. Good, Gaudi, well done. Good, lovely, Gaudi, perfect. Okay, so question 5.1 was out of 3 marks. Okay, so here they're going to give us a mark for making it equal to 0 because A and B are the x-intercepts, so y would be 0. Then they often love to give us a mark on our factors, and then our last mark would be on the answers. Make sure if they ask for coordinates that you give them coordinates, okay, because then they can't penalize you. All right. The other thing that you guys must just take care of is make sure that you write 0 on every single line. Okay, don't get lazy and omit the 0, even if you've written it up here. Make sure you write the 0 on every single line. Okay, good. Gadi, me too. I also got the same answer for the coordinates at the turning point. So a lot of you are saying the coordinates at the turning point are 1 and 18. Oh, did I make a mistake? Okay, Mikhail, what did I write? Oh, sorry. Thank you, Mikhail. I'm being silly. Thank you, thank you, thank you. Sorry, I meant here at B, your coordinate is 4. Thank you so much, Mikhail, for pointing that out to me. Much appreciated. Okay, lovely. Well done. Thank you, everybody. Then calculating the coordinates at C. So I just want to remind you that there are a couple of different ways in which we can do that. Oh, you used the wrong X value when you subbed in. Okay, Cheslin. All right, so we're going to talk now about how we can answer question 5.2. So to be honest with you, by the time you get to matric, you've actually got 4 options for question 5.2. All right. I think if they have given you the equation like they have in this case over here, your quickest and easiest option is to use x equals negative b over 2a. Do you remember that formula from grade 11? Okay, calculates the x coordinate at the turning point. If you did that and you worked with this equation over here, so f of x equals minus 2x squared plus 4x plus 16, the value of b is 4. So this would be negative 4 over negative 2 times the value of a. Sorry, that's supposed to be negative 2. Like so, and then you would end up with 1. So that's one option. The second option is to use your x-intercepts, because remember, your parabola is symmetrical about this line over here. Okay, so that vertical line is your axis of symmetry, and it'll have the same x coordinate as the turning point. So what we can do as a second option over here is we can use midpoint formula. So you can say x equals, and because you've got your x-intercepts, you know that at A, it's negative 2. So I'm subbing into midpoint formula plus 4 at B divided by 2. Can you see you'd end up with 2 over 2? You'd also end up with 1 as your answer. So you can do that as well. The third thing that you can do here, your third option, is to use calculus. Okay, so which I think is probably a bit longer than these two, but you can go f prime x, and you'd end up with negative 4x plus 4. Okay, the gradient at the turning point is 0. So we're going to sub in 0 for f prime x. It's minus 4x plus 4. If I take that minus 4x over to the other side, it's 4x equals 4, and that's why x is also equal to 1. So remember, you've got 3 options at matric level for finding the x coordinate at the turning point. Okay, so any one of those is absolutely a-okay. Then to find the y coordinate, the only thing that you can do is then go and sub your x into f. Okay, Rosaria, I see you've got a hand up. What's your question?
Good afternoon, ma'am.
Good afternoon. What?
Our like premium we had like divided by the by 5.1 and we had to find the coordinates. It was
Uh-huh.
like a negative 5 and none of the numbers could like fit into that 5 and I'm not actually like do decomposing but then I just like got confused. So could you just like explain maybe what I could have done?
Rosaria, I'm actually struggling to hear you a little bit. I tell you what I'm going to do. I'm going to get Yolanda to speak to you, and then perhaps Yolanda, maybe there's just issues with the network and whatever, and then Yolanda can tell me what it is you wanted me to answer. Okay.
Yes. That's
Yolanda,
okay,
will you just help
Rosaria.
Rosaria with that?
Yes, I'll be
Oh, thank
helping
you
you.
so much. Sorry, I was really struggling to hear what she was saying. I heard something about a 5, but I couldn't really make out anything else. Okay, so now we're going to calculate f of 1. We're just going to go and sub 1 in. So here we've got plus 4 times 1 plus 16, and that's where the 18 comes from. And again, grade 12s, if they ask you for coordinates, give them coordinates, and then nobody can take any marks away from you. Okay, and our answer makes sense. We can see that C is a point in the first quadrant, so we were expecting both a negative, a positive x and a positive y. Okay, there's when I first started this question, I said there were 4 methods. I've shown you 3. The 4th method we're not going to discuss because nobody will expect you to do it that way, and you should try and avoid it at all costs. That is completing the square. Okay, so if you wanted to, you could complete the square on f of x, get it into a turning point form as opposed to standard form, but you really don't want to do that. Try and stay away from completing the square as much as possible. It's difficult and time consuming. To be honest with you, I would probably choose either one of the first 2 methods, probably the first one, and just do that. Okay, is everybody happy with 5.1 and 5.2? Oh, it's only out of 2 marks as well, so that must be 1 mark on the X and 1 mark on the Y. That's not very many marks, but all good. All right, lovely. So now let's jump into the third question, where they asked us to write down the range. What does the word range mean, Matrix? What does the word range mean? Can you guys remember? What does the word range mean? Beautifully put into causal. Yes, lovely. Yes, Lebogang, that's great. Perfect. Okay, a set of possible y values, the y values associated with this parabola. Okay, so because this parabola is a sad face parabola, indeed, Gugu, that's a very formal definition. Well done, very nice. Because this is a sad face parabola, it has a maximum. So in other words, there is a y value that is the biggest y value that can be obtained by substituting x values into this function. All right. So in this case, our biggest output is going to be 18, which is the output at the turning point. All the other outputs are going to be smaller. All right. So we would say here that our range, that's it, Nhlanhla. You can write it like that. Perfect. So Nhlanhla has given me this as an answer. He said y is an element of, and then here he used a hard bracket or a square bracket, and then down to, okay, which is absolutely fine. The other way of writing this, of course, Matrix, is y is smaller than or equal to 18. Okay, everybody happy with that? Yes, Lebogang, it's the value of A that determines the shape. So in other words, when we're talking about standard form, so f of x equals ax squared plus bx plus c, yes, this value, or it's not actually the value of A, it's the sign of A. All right, so if that A value is a negative, like it is in this case, then it is a sad face parabola. Okay, if it's positive, then it is a happy face parabola. Okay, quite right. Okay, there we go. Now those are the easy questions. After this, things start to get a little bit more difficult. So that's 18 marks, and so far we've got 6 of them. So 6 out of 18 is a third. So this gives us 33%, but we don't want 33%. We want to try and get a little bit more than that. So that means that we're going to have to be able to answer 5.4 or 5.5, etc., etc. So now here things start to get a little bit tougher. In question 5.4, they say to us, the graph of h of x is the graph f of x plus p plus q, and it has a maximum value of 15 at x equals 2. Determine the values of p and q. So first of all, what sort of graph are they implying h of x is? Is it a straight line? Is it a parabola? Is it a hyperbola? What are they implying that h of x is? Okay, so there's a couple of different answers coming through. A couple of people said it's a hyperbola. Okay, quite a lot of people are saying it's a hyperbola. Why would we think that it would be a hyperbola? What makes us think it would be a hyperbola? What gives you that impression? Can you explain that to me? Why do you say hyperbola? Okay, so we'll wait and see if some answers come through. Oh, here we go. Let's just have a look. Okay, so the x plus p and then the q at the end because of the function notation. That's right, intercausal. Okay, so when it comes to a hyperbola will be in the form, let's call it p of x. It will be a over x plus p plus q. That will be a hyperbola. Okay, so I can see why you would think that, because you've got the x plus p and then you've got the plus q at the end. But the x plus p is not in the denominator of a, right? Also, they're saying h of x equals f of x plus p. So in other words, what they're trying to imply by the functional notation is that h of x is a transformation of f of x. And because it's a transformation of f of x, it also has to be a parabola. Okay. Furthermore, hyperbolas don't have maximums or minimums. Okay, so you can see there, they're telling us that it has a maximum value of 15. Okay, so h of x is also a quadratic function or a parabola. Does that make sense? That's fine, Lebogang. That's why we all here, okay, all here to learn, no problem. Okay, so I'm glad I was able to clear that up for you. So what they're trying to imply in question 5.4 is that a transformation has taken place. Right, f of x has been transformed in some way. Now, the plus q at the end implies that a value has been added onto y. Y in this case is h of x. So when we add onto y or subtract from y, we are translating or shifting the graph up or down. Exactly. Yes, it is normally squared, but can you see here, Kalipa, they have used functional notation. They've used f of x. Okay, so they don't need to put a square on the bracket. What they're implying is that through the notation that they are using, they are implying that a translation has taken place resulting in h of x. They have somehow moved the graph, either translated it left or right or up or down, and that's how we've got our graph of h of x. So when we see the q at the end, the q at the end symbolizes a shift up or down because we have added on or subtracted from y being h of x. Okay, when we add or subtract on x inside the bracket over here, we are implying there has been a what sort of movement? When we add or subtract onto x, what are we implying has happened? Exactly, there is a horizontal shift. Okay, so either we can plus or minus onto y, which moves our graph up or down. Or we can plus or minus onto x, in which case we can move our graph left or right. When q is a positive number, we are moving the graph up. When q is negative, we are moving the graph down. The opposite thing happens with p. When P is a negative number, the graph has been shifted to the right. If P is a positive number, then the graph has been shifted to the left. So we always need to be careful with that when we are working out the values. Okay, so Leanne has offered an answer here. That's fine. They do want the values of P and Q. Let's just see where Leanne got these numbers from. Okay. So they're telling us that this new graph of h of x has a maximum value of 15 at x equals 2. What does that mean? When they tell us there's a maximum value of 15 at x equals 2, what do the numbers 2 and 15 represent? Can anybody tell me? That's it. Well done. Beautiful. They represent the coordinates at the turning point of this transformed graph of h of x. Okay, so originally our coordinates are at 1 and 18. We've now got a x coordinate at 2, so it's moved 1 to the right and it's moved 3 down. So let's call this C prime. And the coordinates here are, sorry, I'm writing x instead of writing 2. The coordinates here are 2 and 15. So in other words, if we now compare what's happened to our x's, it's moved 1 to the right. If we compare what's happened to our y's, we've moved 3 down. Okay, so what do we think our values of P and Q are? Good. So P, a lot of you are saying is -1. Good. And Q is also going to be -3. Okay, so I can write and Q is -3. Okay, the graph has shifted 1 unit to the right. So this is a translation. It's shifted 1 unit to the right. So P is equal to -1. Because by subtracting 1 from x, I move the graph 1 unit to the right. And if I subtract 3 from 18, I'm going to end up with 15. So the graph has moved down 3 units. Perfect. Well done. Is everybody okay with that? Cool beans. All right, so if we understand the notation they use and we understand the information they give us, formulating an answer isn't actually that difficult. Okay, William, I see you've got a hand up. Do you want to ask a question before I move on?
Yes, ma'am.
Sure, William.
Ma'am, I wanted to ask is we said earlier on that the value Q, if there's a positive, it means that the vertical shift is upwards, and if there's a negative sign in front of Q, then it's a vertical shift downwards.
Correct.
So, ma'am, with Q here, we said that it's moving 3 units down. Does that mean that it's not always like that it's going to be moving up because there's a positive?
So if our maximum had been in a different place, so if they had told us that our maximum was, let's just use a different color here. Let's say they had told us that our maximum was at 3 and at 20. So let's work again from this point over here. We'll ignore this one for now, which was the question. Let's just work with this one over here. In this case, the graph would have moved from 18 to 20. So what you're doing, William, is you're comparing x with x and y with y. So if you look at what's happened to your x's, you've shifted 2 to the right. So P would be equal to -2. But now when you compare 18 with 20, you would have shifted the graph up. So Q would be equal to +2 if that was the case. Does that make sense to you?
Yes, ma'am.
Okay, all right. Okay, so the negative here in this case indicates either that your maximum, if your maximum was increasing, then Q would be positive. If your maxima has decreased, like it has in this case, from 18 to 15, then your Q value has to be negative.
All right. Thank you, ma'am.
All right, no problem. Okay, let's go on and have a look at question 5.5. So here they ask us to determine the equation of G in the inverse form. So G, not F. All right, so we haven't worked with G yet. Let's highlight it in a different color. Let's grab a yellow. And here's our graph of G. Okay. Are you guys able to do that on your own? Can you find the inverse of G in the form Y equals? I'm going to let you try that. So I'm going to give you a couple of minutes to do it, and then I will mark it with you. Okay. So you guys are going to try question 5.5 on your own.
Jelly, can we scroll a little bit up so that we can see just what's done there, so we can see the
Is that
X
better?
coordinate?
There we go. There we go. There we go.
Yes,
There we go.
thank you.
All right. No problem. Thanks, Yolanda. Okay, Lucejo, I'm going to answer you now. Let me just see what you've done. Okay. There you go, Lucejo. Okay, so a whole bunch of you are busy DMing me the answer. Let's see what you can. So Iviwe, that's lovely. Well done. Good, Gugu, no problem. Okay, going back here, Yamkela. All right, I see you have a question about 5.3. That's fine. Yamkela, ask you a question about 5.3. What's your question? You can unmute if you'd like to, Yamkela. It's easier than typing a
Good
question.
evening, ma'am.
Good evening, Yamkela.
Yes. How do we know that we include and exclude the in 5.3?
Okay, so because the question is asking about range, we would include because 18 is an output. Okay, so in other words, it is allowed to equal 18. It is equal to 18 when x is equal to 1. So you will include 18. So where you would exclude a value, for example, would be like if there was an asymptote, which in this case there wasn't, or if they said to you, for which values is X increasing or strictly increasing, then you wouldn't include like the turning point, the X coordinate at the turning point. Okay, so it's because of the question that they're asking. That's how we know that we're supposed to include. So all range questions will include.
Yes, ma'am, I understand.
Okay.
Oh, yeah.
That's fine, Amatla. I'm glad that you joined us. Okay. Okay, so as far as question 5.5 is concerned, there's a bunch of you that have sent through answers. Remember, when we do an inverse, we have to switch X and Y. So that would be the first thing that we would do. So we can write down G minus 1, and then we can go and switch X and Y. So we would end up with X is equal to 2Y plus 4. Now we have to make Y the subject of the formula. So that means we'll have to take the X over to the other side and then divide every term by 2. Okay, so that's how come we end up with half X minus 2 is equal to Y. Generally speaking, we would write it with the Y first, but it doesn't matter if you don't. I mean, the other thing that you could do is put that over 2, but we should always just try and simplify where it is possible for us to do so. Okay, or the other way that we could write this is like that, but they did say in the form Y equals. Okay, all right. So everybody okay with 5.5? Can we go on to 5.6? We all good? 5.5 only out of 2 marks. So 1 mark for switching the X and the Y, and the other mark for the answer. Oh, good. All thumbs ups. All right. Lovely to see that. Okay. Now jumping into the definitely more difficult sorts of questions. All right, so now it says to us, for which value or values of X will G to the minus 1 of X times G to the X be equal to 0? So now I've tried to do a few questions like this with you guys in the past. I know I also did it when we did the focus sessions on a Saturday. These are this is the sort of question that a lot of students look at and they don't understand what it means. So they don't even try and answer it. They just sort of leave that question and move on, right? So I'd like to try and explain to you what it is that, what it means, what we're actually looking at. First of all, we're multiplying two things together. Okay, so G minus 1x and G of x represent Y values, output values. So we're talking about Y values on the inverse times Y values of the graph of G. When we multiply these two together, we want to get 0 as an answer. So when we multiply two numbers together and we get 0 as an answer, either this must be 0 or this must be 0. That's the only way. One has to be 0. Quite right, Gugu. Okay, so when we multiply two numbers together and our answer is 0, either one of the two numbers has to be 0. Now, where is Y equal to 0? At the x-intercepts, absolutely. Right, so now we want to times these two numbers together and we want to get 0 as an answer. So it's either where the inverse is equal to 0, so its x-intercept, or where g of x is equal to 0, which is its x-intercept. So for which values of x will this happen? What they're actually asking us to find are the x-intercepts of both functions. Okay, does that make sense to everybody? That's what they want from us. So in 5.6, the x-intercept of g of x, first of all, so making y equal to 0, we've got 2x plus 4, so that'll be minus 2x equals 4, so x would be equal to negative 2. Okay, so if x was equal to negative 2, then the value of this will be 0. Or the other place is where this graph is equal to 0. So here we said our equation was 1 over 2x. Was it plus or minus? It was minus 2 equals 0. So now what I'm going to do is take my 2 over to the other side and times both sides by 2. Okay, so either where x is equal to negative 2 or where x is equal to 4. So where x equals negative 2 or where x is equal to 4. Okay, so 2 marks there. They're not giving us a lot of marks on our working out. Probably just on our answers. Are we all okay with 5.6? We feeling good
All
about
good,
that,
ma'am.
love? Good. Thank you, Jared. Oh, nice. All right. Cool beans. Okay, so let's jump in. Sure, Mamelo, that's no problem. I'll scroll up again because we are now going to attempt our last question. Okay, so now they say to us in 5.7, if P of x equals f of x plus k, determine the values of k for which P and G will not intersect. Now that's out of 5. So if P of x is f of x plus k, determine the values of k for which P and G will not intersect. Now, believe it or not, this is a question that goes back to grade 11. And one of these sorts of questions where they ask you to determine a value of a variable for which two graphs will not intersect is actually an application of nature of roots in functions. Okay, so we're going to have to use the discriminant in order to be able to answer this question. First of all, let's get an expression for P of x. Okay, so this is question 5.7. P of x is f of x plus k. So we know that f of x is minus 2x squared plus 4x plus 16. So I'm going to sub that in. Minus 2x squared plus 4x plus 16, and I'm going to bring down my plus k. So there's P of x. Now they want us to solve for the values of k for which P and G will not intersect. Now this seems a little bit strange because we're saying that they're not going to intersect, but this is the application of the nature of roots. What we need to do now is we need to equate P, and G, get it into standard form, and then answer our question based on the value of the discriminant when graphs are not intersecting. So what I'm going to do now is I'm going to make minus 2x squared plus 4x plus 16 plus k. I'm going to let it equal g. G is 2x plus 4. And then I'm going to move these two terms, the 2x plus 4, over to the left-hand side. And I'm going to get it into standard form. So I've got minus 2x squared. This will become minus 2x. So this is plus 2x over here. This is minus 4. So I'm going to minus 4 over there. So that would be 12 plus k. And now it's equal to 0. It's in standard form. So remember at the top, we were writing standard form. I rubbed it out. Standard form is ax squared plus bx plus c equals 0. So in this case here, matrix, the value of a is -2. It's the coefficient of x squared. The value of b, the coefficient of the x term, is 2. And the value of c is everything else. It's 12 plus k. Oh, what on earth is that? Sorry, I don't know why it does that sometimes, but it likes to change what I've written into a shape. Now, when they say not intersect, what this means is that the roots are non-real. Do you remember that from grade 11? Okay, so when a straight line and a curved function do not intersect one another, we would say that the roots are non-real. They don't exist. When the straight line touches the parabola or another curved line in one place, then we say that the roots are equal. And if they intersect in one place or in two places, then we would say that the roots are real. Is this kind of coming back to everybody? There we go, absolutely. So, and Ntlanhla's put a clue there for us. He says delta has to be smaller than 0. This is true for roots that are non-real. Okay, delta is smaller than 0. Okay, and remember, delta is b squared minus 4ac. Okay, so this is our equation in standard form. We know what our A and our B and our C are. So what we do is this. We are going to solve b squared minus 4ac is smaller than 0 because the roots are non-real. And now we need to sub in. So b is 2. So 2 squared minus 4 times a in this case was -2. And c is 12 plus k. And I'm going to solve for k when delta is negative smaller. Yes, we're using the discriminant. Quite right, Lindelwa. That's exactly what we're doing. Okay, so this is an application of nature of roots in functions. Okay, and that's why it's the last question, because it's also the most difficult question that they're asking here. Okay. The clue Lebogang is where they say determine the values of k for which p and g will not intersect. So, and the fact that they've made it out of 5 marks means that they want you to use algebra. It's not just a case of looking at the graph and you can just write down the answer. Okay, so the clue here was the not intersect. That's how we know that they're using nature of roots. Okay, because equal roots or tangent means delta is equal to 0. Will not intersect means non-real roots, delta is negative. That's very true in Ntlanhla. Good, yes. Okay, so not an easy question at all. Not something that we see very often, but it does come up. Okay, so now it's a case of solving it. The easiest thing for you to do here is this. So 2 squared is 4. Then say -4 times -2 is +8 and leave that on the outside. So we've multiplied these two numbers together. And now let's what's the word? Distribute into the brackets. Okay, so 8 by 12 would give us 96 plus, oopsie, that looks terrible, sorry, what I'm doing. Okay, 8k is smaller than 0. So this would be 100. Plus 8k is smaller than 0. So now what I need to do is I need to take that 100 over to the other side. So I've got 8k is smaller than, and I'm taking the 100 over to the other side, so it's negative, and now I'm going to divide both sides by 8. Okay, so k must be smaller than -25 over 2. Okay. And that's how we would do that question. That's at -12.5 is correct. All right, so Yolenda's popped the quiz for this evening in. Are there any last questions about question 5.7 before we say goodbye? Sure, Iviwe, what would you like to ask? Sure, Kalipa. Okay, where did we get 12 plus k? Okay, so Leanne, the 12 plus k, Kalipa, I'm just going up again, was obtained. So remember they told us that p of x was equal to f of x plus k. So we had to introduce or add k onto f of x. Then they told us to solve for those values of k for which these two graphs do not intersect. So when we made them equal and we took the 2x over to the other side and the 4 over to the other side, it was the 16 minus the 4 that gave us the 12. So that's where 12 plus k comes from.